This is Nathaniel Cole. Today we are now going to do question 4 of 2017. What line rope allows the horse to reach precisely half the area of the field? So we require that the area of the field is half. So r squared theta over 2 equals to half. So theta equals to pi over 2. So this means r squared equals to 2 over pi. You can't rationalize this. R equals to the square root of 2 over pi. And if you have a list of constants, please put this in. So another horse is placed in the field attached to the corner diagonally opposite each horse. Explain why the area both can reach is the same as the area neither can reach. Both horses can reach half the area of the field, so without overlap, these would sum up to 1. That's the same area as the total field. Hence, the overlapping area between the two corner circles must equal the areas outside. So the angle alpha is marked in the diagram above. Show that alpha is cos inverse root pi over 2. So this means to calculate alpha, distance from bottom left to corner of square the center and square root 2 over 2. Hypotenuse is the radius calculated, so square root 2 over pi. So cos alpha equals to the square root of 2 over 2 over the square root of 2 over pi equals to root pi over 2. Again, if you have a list of constants, please put this in. Pi over 2 and cos inverse pi over 2. And please put it in radians. A third horse is placed in the field and the 3 horses are rearranged. One horse is now attached to the midpoint on the bottom side. Another horse. Even each horse can access equal area and then none of the areas overlap. Where each horse has to minimize the area. So 2 distinct shapes will be on 2 half circles and 1 quarter circle. So pi r squared over 2 equals to pi a squared over 4. So this means that 2r squared equals to a squared. So to calculate r, we have to realize that the diagonal distance is the same. So this means set r equals to, so we have to set r equals to 1 over twice the square root of 2 because the half the diagonal is actually root 2 over 2 or 1 over root 2. R is 1 over 2 root 2. Again, if you would like to rationalize their denominators, please write this as root 2 over 4. So, using this relationship, we know that A equals to half. There. So, the horses on the bottom left midpoints are each replaced by a goat. The remaining horses attached to the upper right corner. Given that 0 h1 and none of the animals can overlap, show that root 1 over 2 holds an area in the area the animals can reach is maximized. So this means that 0 is less than g less than square root of 2 over 4. So let's write a proper 0 here. So we can relate to g to h as g plus h squared equals to 0.5 squared plus 1 squared by the Pythagoras. So set g, and we calculate this is the square root of 5 over 4 minus h. As we know, the maximum h can be 1. So the actual range for g is the square root of 5 minus 2 over 2 less than g less than 1 over 2 root 2. There, that was the quick one, which involves some geometry. So, see you in a bit.